It became very clear to me pretty quick that you guys were struggling with solving linear equations. You should already know how to solve linear equations. You should be experts at it, but it's because that's something that you're doing in secondary 1. Yes, sir.
On this, I thought we were only supposed to go to question 4.
Okay, then this can be due next 8A. If there was any confusion on that, does that work? Okay. Because there was confusion with the computer, so I can say that's a valid point. Okay? All right, but I did feel like I swear I said watch the video. I don't know. It doesn't matter. Okay. All right, so it became very clear to me last time that you guys really are, like, you're not where you need to be when solving linear equation, and that's a huge problem, and I really stewed about it over the weekend. Okay, what do? I need to move on because all the other teachers are already ahead of us, but I really debated, like, do I move on? Because if you move on and you don't know something, where it's just going to be a never-ending spiral into disaster. So I've made the decision to spend another day on solving linear equations. With that being said, after today, you should be experts in it, okay? Experts. So I'm going to go really slow, because after last time I was like, whoa, they do not know this. So we're going to go really slow, make sure we're good, because wouldn't you rather know it than just move on? Yes, me too. All right, so solving linear equations. I'm going to treat it like you've never learned it, even though you have for 2 years learned it. We're going to go over it again, okay? I'm going to ask you a question. Why are linear equations considered linear? Let's make sure my thing's videoing, first of all. Yeah, it is. Okay, why are linear equations considered linear? What makes an equation linear? Does anyone know? Yes. What? One answer. Yes, that is true. Good point. There is going to be one answer. That is very true. Good point. Is there anyone else that can tell me why this would be considered linear? That is one of the reasons. Yes. Good. So it is going to graph a line. So you're able to see that this is going to graph a line. And what I'm trying to get at, guys, is notice all of our variables are degree 1. Does everybody see that all of our variables have a 1 because they're just x's? Does that make sense, everybody? So that's what solving linear equation means. We're going to be just dealing with x's, simple x's, but really it's x to the degree 1. Good point. These are all lines. Good point. There's going to be one answer. Yes. Okay, good point. And now notice this, guys. This is a fun fact for you. Depending on what type of equation we're solving, you're going to know right away how many solutions you should get from the exponent. So this is just a side note. Since this is degree 1, you're going to have one answer. If it was an x squared, you're going to have 2 answers. If it was x cubed, how many answers would you have? 3. That's called the fundamental theorem of algebra. That's just a side note. But the fundamental theorem of algebra sounds fancy, but that's all it means. However many exponents you have, whatever degree it is, that's how many answers you'll have. Okay, so let's go through and talk about how to solve a linear equation. Okay, so we solve linear equations by solving for x. Ultimately, our goal is to solve for x piece by piece. You're going to hear me say that a lot. We're piece by piece going to solve for x. Our goal is to get x all by itself, or to isolate x. Okay, well, this means we're going to be moving things from one side of the equation to the other, and we have to do that correctly. We have to be really careful to do that correctly. Now, we move things from one side of the equation to the other by using inverses, and we have to use the correct inverses. So, the inverse of multiplication is division. Same with division, guys. The inverse of division is multiplication. Now, guys, what does inverse mean? It simply means it undoes. Inverse means undoes. So, multiplication undoes division. Division undoes multiplication. Same with addition. Addition undoes subtraction. Subtraction undoes division. They're inverses of each other. So these are the things that we're going to be using to get from one side of the equation to the other. Does that make sense? Yes. Okay. All right, so let's start out very, very basic because last time I just jumped right into the hard stuff and it made everybody lost. So we're going to start very basic. So looking at this first example, we have x plus 2 is equal to 3. We're going to piece by piece get x all by itself. So looking at this, we have an x plus 2. It's connected to our x by our plus 2. What undoes addition? Subtraction. So we're going to subtract 2 from both sides. So then on the left, we have x and we have positive 2 minus 2. Doesn't that add up to be 0? That was the whole point, right, everybody? Okay, so x is equal to, what's 3 minus 2? 1. And there's our answer. Now we could check that by putting it back into the original wherever there's an x. So we could have done 1 plus 2 is equal to 3. If this is a true statement, then we've probably done it right. So 3 is equal to 3. Is that a true statement? So we've done this correctly. Okay, let's do another one. Starting very basic. I understand that. We're starting basic. We have 2x is equal to 12. Ultimately, we're trying to get x alone piece by piece. Now notice, my 2 is multiplied to my x. So what undoes multiplication? Division. So we're going to divide both sides by 2. So then over here on the left, those divide out to become 1. So that leaves us with x is equal to what? 6. Now once again, let's say I really wanted to check this answer. You could plug it back into the x, into our original problem. So that would have been 2 times 6, which was equal to 12. Let's see if that's a true statement. 12 is equal to 12. Check, we've done this correctly. Starting very basic, and that's going to help when we get harder and harder, I promise. Let's do a little bit more advanced now. A little bit more advanced, and we're going to keep building. So we have negative 2x minus 3 is equal to 11. Once again, negative 2x minus 3 is equal to 11. Piece by piece, we're trying to get x all by itself. Piece by piece, we have to do this correctly. So first of all, to get x alone, I'm going to, first of all, this is minus 3, so what should I do? Add 3 to both sides. So that leaves me with, on the left, right now, I'm going to show all my work. Negative 2 is equal to, what's 11 plus 3? 14. And now from here, we're taking another step, trying to get x alone. What's my next step? Divide both sides by negative 2. Divide both sides by negative 2. So then that's gone. That was awesome. Now we've reached our goal. X is all by itself. What's 14 divided by negative 2? Negative 7. Now once again, we could go back. We could plug it into our original problem, and we could check it. And on a test, it might even say, show me that you know how to check an answer. Show me every single step. Okay? So let's practice that really quick. So we have negative 2 times, we're plugging it into our original problem wherever there's an x. So that would be negative 7 minus 3 is equal to 11. Let's see if this gives us a true statement. Negative 2 times negative 7 is positive 14. Minus 3 is equal to 11. Is everybody following? So 11 is equal to 11. 14 minus 3 is 11. Check, we're awesome. We got it right. Let's move on to the next example. A little bit harder here. A little bit harder. We have negative 3x minus 3 is equal to negative 2x plus 22. Piece by piece, we're trying to get x all by itself. But notice, on the right there's an x, on the left there's an x. Can we combine x's though? Yes, but we've got to perform the correct operation to get one x from one side of the equation to the other. Now it doesn't matter if we choose to move this way or this way, as long as we're using the correct operations, we're going to find the same answer and the correct answer. So what I'm choosing to do is I'm going to combine my x's first. So I'm going to go ahead and I'm going to add 3x to both sides. Now the reason I'm adding is because it was subtract, right? Is everybody following? Add 3x. So on the left, what that leaves me with is negative 3 because that became 0. Negative 3 is equal to, now I'm going to carefully add these. Negative 2x plus 3x's is positive 1x's. And I just put x and everybody feel comfortable with that. Positive 1x is just x. So we have x plus 22. Now what's our goal? We're trying to get x alone. We've got to do it piece by piece by applying inverses from one side of the equation to the other. How do I get x alone at this point? Subtract 22 from both sides. So we have negative 25 is equal to x. Is x isolated? Yes, x is all by itself. Our answer is negative 25. If it's written negative 25 is equal to x, that's the same thing as x is equal to negative 25. Now we could check it by plugging it back in. I'm not getting you right now. Is that okay with everybody if I don't check it? Okay. Let's get a little bit more advanced. Here we go. So we have 75 is equal to 3 times negative 6n minus 5. Now, once again, remember, we're solving for a variable, piece by piece, and we've got to do this in the correct order. There's a couple different ways we can go about solving this problem. Because we just have to make sure we're getting n alone, piece by piece, in the correct order. So I'm going to choose to do it one way. You might choose another. We can go through both if you want to see another way, but I'm just going to go through this right now like this. Okay, first of all, let's focus on the left. We have 75. Nothing to combine with 75. So I'm going to write 75. Now I'm going to focus on the right. Can this piece simplify further? Yes. Now, is 3 being multiplied to all of that? Yes. So we've got to distribute. Now, this is the reason, guys. The 3 is right next to the parentheses. So we know for sure it's multiplication. Can I help you? Okay. Come like after school or something, please. Sorry. Or after this class. Okay. So let's go ahead and multiply the 3 through. So we have 3 times negative 6n. What is that? Negative 18n. All right, then we have 3 times negative 5. Being careful, what is it? Negative 15. Now, piece by piece, let's solve for n. Piece by piece, let's solve for n. So now I've simplified the left, I've simplified the right. Piece by piece, we're trying to get n alone. What should we do? Add 15 to both sides. So what's 75 plus 15? So we have 90 is equal to negative 18n. Questions? Now what am I going to do? Divide by negative 18. Divide by negative 18. Now this is where you get out your calculator, you would type that in, and what do you get? Let's practice with our calculator, guys. Negative 5. So we have negative 5 is equal to, those divided out, so it's equal to n. Any questions? Okay, let's do a little bit harder one. 10p plus 9 minus 11 minus p. That's what's on the left. Once again, on the left, we have 10p plus 9 minus 11 minus p, which is equal to negative 2 times 2p plus 4 minus 3 times 2p minus 2. Now, to many people, I'll let you write that down. To many people, this looks kind of terrifying because it's huge. But really, if we just focus on the left and simplify that, and if we focus on the right and then simplify that, then piece by piece we can solve for the variable, and it won't be so hard. But you do have to kind of look at it in pieces, or else, yeah, you're going to make some errors. So I'll let you get that down, and then we'll go through it. Okay, so I'm going to focus on the left here. I'm going to simplify that. We know how to combine like terms, so let's combine all like terms. 10p minus 1p is how many p's? 9p. And then we have positive 9 minus 11, which is negative 2. Is everybody comfortable with what I did on the left? Which is equal to, now I'm going to focus on the right. Now this is where it's a little bit trickier, and this is where most of you last time were like getting it wrong and saying, I'm lost, I don't know what to do. So you should all be watching carefully. So we have to decide what's being added and what's being multiplied. Now that's where most of you were getting confused last time. Okay, looking at this, we have negative 2 right next to the parentheses of all that stuff. So we know for sure that negative 2 is being multiplied. Does everybody see that? Now, if we would have changed that up and had 2 minus 2p plus 4, everybody look, because this is where most of you raised your hand and said, I'm going to multiply all that stuff through, right? Right there? No, guys, is the 2 right next to the parentheses? No, so that would have not been, you would have just added 2 and negative 4. You would have simplified that down. Okay, so I'm going to erase that really quick. Okay, so let's go through and simplify this. This negative 2 times all that stuff. All right, so negative 2 times 2p is negative 4p. Then negative 2 times by positive 4, what's that? Negative 8. Very good. Now let's look at the next piece. I'm going to ask you, is the negative 3 multiplied to all that stuff? Yes, it's right next to that parenthesis. So we know it's multiplied. So let's multiply it through. Negative 3 times 2p. Negative 6p. And then negative 3 times negative 2. Plus 6. Okay. So now piece by piece, we'll go through and simplify this. Now once again, I'm showing all my work on this one. On the left, that doesn't simplify any further. So 9p minus 2 is equal to, but on the right, we can simplify this further. Let's combine our p's. Negative 4p minus 6p. Be careful. Negative 4p's. You subtract 6 more p's. How many p's? Negative 10 p's. Very good. And then we have negative 8 plus 6. Negative 2. All right, so now on the left it's simplified, on the right it's simplified. So now we can go through and piece by piece solve for the variables. Is everybody following me? Okay. Something interesting happens with this one. Okay, let's go through. So once again, we can either subtract 9p from both sides or add 10p. So I'm going to go ahead and add 10p to both sides. Now the reason I'm adding is because it was minus, so plus 10p plus 10p. So over here on the left, I have 19p minus 2 is equal to, those added up to be 0, negative 2. I'm trying to solve for p, piece by piece. Any questions here? So what's my next step? Add 2 to both sides. That leaves me with 19p is equal to, what's negative 2 plus 2? 0, okay? Piece by piece, I'm trying to solve for p. I'm trying to get it along. What's my next step? Divide by 19. Divide by 19. So that leaves me with p is equal to, I'm going to come over here. P is equal to 0 divided by 19. Now I'm going to have you, for a very specific reason, type that into your calculator. What's 0 divided by 19? Do you get an answer? Yes. What's the answer that you get? Okay, 0. So p is equal to 0. Very good. So p is equal to 0. Now the reason I made such a big deal about that is because, what if? Now this is where you're going to want to watch, because you didn't know this last time. So I was walking around the room and you had the wrong answers. What if I changed the problem? Let's say we simplified this down, and instead we would have had, instead of this, what if we would have had this instead? P is equal to 19 divided by 0. If you try to type that into your calculator, what do you get? 19 divided by 0. What do you get? Error. Error. Your calculator says error. Now here's the reason, guys. 0 is on the denominator of a fraction, meaning you're dividing by 0. You guys, you can't divide by 0. You cannot divide by 0. It is undefined. Okay, so if you ever are dividing by 0, you would say undefined. We can't divide by 0. Actually, dividing by 0 is a very complex thing. We could go into why you can't divide by 0, but that could take us a while and you're not going to really quite grasp it. But you just have to know you cannot divide by 0. You can have 0 divided by a number, because if you start with nothing and you divide it by 19, you're still going to have nothing. But you can't take 19 and divide it by 0. Does that make sense? Okay. Okay, awesome. Moving on. Oh, that's what I just went over. So you can't divide by 0. All right, let's do another one. I'm doing all these for a reason. They all have a specific reason I'm doing them. I'm not just like throwing these on the board without thinking them through. So I'm doing them all for a reason, to teach you something so that you'll be set up for success on that worksheet. So I would be watching. So we have negative 12 times x minus 12 minus 4 times 1 plus 3x. Let's go through this piece by piece. So now once again, it looks kind of scary right now because it's this huge jumbled mess, but it's really not that scary if we go through and simplify the left and then simplify the right and then go through and simplify this. So I'm going to focus on the left for a second. Is the negative 12 multiplied to all that stuff? So let's distribute it through. Negative 12 times x is negative 12x. And then we have negative 12 times by negative 12. Positive 144, very good, which is equal to, let's focus on now the right. Is negative 4 multiplied to all that, or is it added? It's multiplied, it's right next to the fraction. Negative 4 times 1. Negative 4 times 3x, negative 12x. And now once again, I strongly suggest you not skipping steps. And I would simplify the left if possible, simplify the right if possible further. But it looks like it's simplified on the left, and it's simplified all on the right. Okay, so now let's go ahead and piece by piece solve for x. So we're trying to get x alone piece by piece. What am I going to do? Add 12x to both sides. Why not? Add 12x. Now we have 0 plus 144 is equal to, I'm doing this for a reason. So on the right, we have negative 4 plus what? Plus what? 0. So wait, we have 144 is equal to negative 4. What the heck? Our variable went away. Yikes. Okay, now that does happen. That does happen. Now you'll look at what you have. Is that a true statement? Is 144 equal to negative 4? Not a true statement. So the answer would be no solution. Now what if your variables cancel out and you got a true statement? Let's say your variables cancel out and let's say you got something like this. Negative 5 is equal to negative 5. Is that a true statement? Yeah, that's true. So that would be, that happened, you would say all real numbers. So once again, does everybody understand? If your variable cancels out, you have two options. Either no solution, if you didn't get a true statement, or all real numbers, every number, if you get a true statement. Does everybody understand the difference? Okay. Awesome. Now also just keep in mind, guys, you're going to be seeing, depends. You guys are in secondary 3 now. All real numbers, you might see the sign like this. It's just like a fancy R. That means all real numbers. That's the same thing as writing out all real numbers. And I've seen it both on the end of level test. I've seen both on the ACT. So they'll have, like, on the ACT, it's multiple choice. And I've seen answers say all real numbers. And then I've had, like, a different problem have the sign all real numbers. So if you didn't know what that sign meant, you would not know how to do that. So just keep that in mind for future. Okay. Let's do last example, and then I'm going to let you work. So I am doing every single example for a reason. So this is what I just talked about. And then I'll let you work. I'm doing these for a reason. I didn't just put them on the board to be up here teaching and bore you. I'm up here for a reason. I promise that every single one of my examples had a purpose. So let's go through this one. We have negative 11 plus 10 times p plus 10. Which is equal to 4 minus 5 times 2p plus 11. I'm going to let you write that down. Now, this is the one that really threw most of you for a loop. This is the one that almost every single one of you missed. It was like the first problem on the last worksheet, pretty much, one similar. So we're going to go through it. Now, it looks huge right now, and it is. It's this huge jumbled mess, so why not make it simpler on ourselves, and let's focus on the left side and simplify that. Focus on the right side, simplify that. And then we can go through and combine everything. So on the left, is the negative 11 being multiplied to all this stuff? Being added. Okay, interesting. Is the 10 being multiplied to p plus 10? So let's distribute that through. 10 times p, so 10p. And then we have 10 times 10, which is positive 100. And then we're not going to forget about this negative 11. And it was being added to all that stuff. Okay? Any questions? All right, now on the right here, let's go through and simplify this. We have 4 minus 5 times all that stuff. What's being multiplied to all that stuff? 5 or negative 5. So we'll take negative 5, multiply it to, well, first of all, I'm going to drop my 4 down. Okay, I'm going to drop my 4 down. Negative 5 times 2p. negative 10p, and then negative 5 times 11. Negative 55, and then we won't forget our equal sign. Now, once again, I'm going to still focus on the left, and I'm going to simplify that further. I'm going to do what? Sorry? Somebody said it? Combine, yeah, good. Combine negative 11 with 100. So we have 10p plus 89 is equal to, now let's focus on this piece, 4 minus 55. Good, I'm glad that you said negative 51 because you're correct. Negative 51, 4 minus 55 is negative 51, and then minus 10p. Okay, now let's go through at this point and piece by piece solve for p. So we can either bring the p's over this way or the p's over this way, but you have to do it correctly. So I'm going to add 10 p's to both sides. So we have 20 p's plus 89 is equal to negative 51. Any questions up to there? So then I'm going to do what? Subtract 89, subtract 89. So we have 20p is equal to negative 140. And my next step will be to do what? Divide both sides by 20. So we have p is equal to, now most of you are going to need a calculator. You should have a graphing calculator by now. So negative 7. Okay, questions? Okay, I'm going to give you a while to work on problems for a second, 1 through 17 on the worksheet, and then I'm going to bring you back to me in a while, and we're going to make sure we know what domain and range is, because you've got to be able to do domain and range. So work on those problems for a second, and I'll be walking around checking your answers. Please raise your hand if you need me to check your answers. Right now you can. Okay, so we need to re-talk about, just look back on domain and range. We've already learned this once. We're talking about it again, making sure we're good to go with domain and range. So make sure you're paying close attention, taking good notes, and whatnot. So remember, domain is x values. Now when we're talking domain, guys, we're talking left and right. We're looking left and right. Now remember I talked about how important it is that your eyes only look left and right. We only care about left and right when we're talking domain. Sorry, I've been talking a lot today. And then our range is y values, are up and down. So you have to shift your eyes and say, I only care about where my function's growing up and down. Does that make sense, everybody? We've learned this. Awesome. Okay, so let's just do an example here because we have to look at it a little bit differently today. Looking at it a little bit differently today. So looking at this example here, you're not going to be able to draw this one necessarily, so it's probably going to be more beneficial for you to look. Now, domain and range, guys, is really hard for a lot of students. It really is. So you need to be watching, making sure you're asking questions if you don't see it. All right, so domain is x values, left and right. So looking at this crazy function here, looking from left to right, I don't care how far up or down it is at all. I do not care that it's clear up there and clear down there. This doesn't matter with domain. We're talking from left to right. Where does our function start? From left to right. It's at negative 3. We're looking left and right. It doesn't matter that it's down here. I'm talking left and right. It starts at negative 3. Did it include negative 3? Did it include negative 3? It's an open circle, so that would mean it doesn't include negative 3. So to say it doesn't include it, you put a parenthesis. Okay? So negative 3. We're not caring that it's down. I'm talking left and right only. Left and right. So now, where does it go from left to right? Where's 7? Positive 7. Does everybody see how our function grows till it hits that wall at positive 7? Left to right. There's a wall at negative 3. There's a wall at 7. Does it include 7? It lands right at the 7. Good. And so we've got to put a bracket. Questions on that? Yes?
What's the difference between an open and closed circle again?
It just means like it hits right there, but it isn't including it. So anything that's this way of it will be included. So even like points negative, or like for example, negative 0.6, negative 6.99999, that's really, really close to 7, right? but when it hits 7, it's not included anymore. Does that make sense? So you gotta still put the 7 because we're hitting 7 but not landing right on 7. We're getting really close to 7 but not on 7. So open circle just means parentheses. That's how you specify you know it's not actually landed on 7. Okay, good question. Any others? Okay, let's talk range now. You got to shift your eyes. So we don't care how far left and right this is. Now we're talking range. We don't care how far left and right. I'm talking up and down. Up and down. Where does it start on the bottom? -10. Very good. And did it include -10? Open or close circle? Open, so it didn't include it, so we got to put a parenthesis. And then, where does it hit? +9. Very good. And it did include 9, so, because we're talking how far up and down, so bracket. Questions on domain and range? On this one. Last one, and then you should be able to finish up everything, so watch because you're going to want to watch. These are the ones that take a little bit more of advanced thinking. Last example here. Okay, it's asking us to make a graph that fits the domain and range provided. So the reason it's a little bit harder is because we're not given the graph. We're going backwards. They're going to say, you provide a graph for me, but that fits this domain and range. So with this one, we just have to be careful. So first of all, I'm going to focus on domain. Now, domain is left and right. Doesn't matter how far up and down we're talking. No, right? Domain is left and right. So let's focus on left and right first. So it says, domain is all real numbers between and including -10 and 6. So all numbers between and including, so closed circle or open circle, which one? Closed, okay. Between and including -10 and 6. So what I'm going to do is left and right, I'm going to go to -6, or -10, and I'm going to make a wall. This will help you draw your graph. I'm going to make a wall like this. And I have to make it a dotted line so that I know that you're not drawing that as your function. Or it's not a function, graph. So I'm going to make a wall. Now, the reason it can go doesn't matter how far up and down it goes. So that's why I'm drawing it the whole way, because it doesn't matter. Now I'm going to go to +6. I'm going to draw a wall. This will just help you not get it wrong. Okay, +6. Now, once again, can everybody see how that would be a domain from left to right between -10 and 6? Is everybody okay with that? Sweet. Now we're going to focus on our range. So range is all real numbers. Now, if our range would have been let's say our range would have been -2 to 1, that would have been easy. We would have drawn a dotted line at -2 and 1, and then we would just do a function that starts over here and doesn't go above that or below that, and it doesn't matter what goes in between, right? As long as it stays within that boxed area. So this one means range needs to be all real numbers. So our graph needs to continue that way forever, right? And down forever, right? So we can draw any graph that fits this. So my graph's going to probably look different than your graph, and that's okay. As long as it doesn't, I'm going to draw, for example, a graph that goes up here forever. And it's going to have to come over here and touch somewhere, but then it can't go past that, and it's going down forever. The in-between doesn't matter. Does everybody looking at this, can you see how our domain is still from -10 to 6? And our range is positive infinity to negative infinity. Does everybody see that? Is everybody comfortable with that? Now, once again, I saw some way confused faces when I started to say, do you want me to change the range and do a number? Or are you okay? Like, do you need to see another example of, like, if the range was given? Or do you understand how it would work? You're all good. Sweet. Now you can finish up last time's worksheet and today's worksheet, and that'll be due next A day along with what we're learning tomorrow. So yes, 3 assignments will be due next A day. You will not put your stuff away until the bell rings, because you all have stuff to be working on. Work until the bell rings. Do not waste any of the class time that I'm providing you with. I would love to help you individually. Raise your hand. I would love to check your answers. Raise your hand. I'll be walking around.